Hello everyone, this is Balaji KS signing in for Brain Smart Labs. In our previous session, we understood what is method overloading.
Yes!
Today is a big day as we're going to start with a brand new topic, constructors. Let us not waste much time. Let us take a quick recap on what we did in our previous session. In our previous session, half encapsulation and half polymorphism, we gave you the clear-cut interview definitions for what is a class, what is a template, what is encapsulation, and why encapsulation should be performed while writing our code. Encapsulation is done inside a class template to reuse the code again and again multiple times by using its objects. In our yesterday session, we also saw the second main pillar of OOPS, polymorphism, wherein we understood polymorphism is a phenomenon wherein one method, aka behavior, is exhibiting many forms inside a single class template. We understood method overloading with an example of class test, which was containing 5 different methods of various method signatures, but all were bearing the same method name as fun. In method overloading, as many are having the same method name, to invoke a write method, we have to pass a matching set of arguments which tallies with the method signature of what we are trying to invoke. Confusion alert. Method signatures do not include any return type, and so method overloading in Java is completely independent of return type declared to the left of a method. Many on WhatsApp yesterday messaged me asking why we have to overload a method. This is a common question by all students. What is the main purpose of overloading a method? Frankly speaking, I have not taught you the main purpose of polymorphism yet.
Oh no!
Let me confess straight to you, polymorphism is a very big topic.
What?
I cannot make you understand everything in one single day, just like other tutors do. From day one I am repeating, I am not teaching you Java here. Instead, I am teaching you OOPS using Java language.
That is correct.
If you learn OOPS perfectly using Java, tomorrow learning Python or learning JavaScript would be very easy, as they all incorporate the very same OOPS programming model.
Okay.
The problem with you guys is you choose a very simple and an easy computer language to understand programming. ಅಲ್ಲೇ ನೀವೆಲ್ಲ ಎಡಬೋದು. Writing your jujube hello world program, addition program, factorial program is easy in any programming language. Your Dabba friends who are trying to brainwash you, learn this, learn that, will also be working on the same Dabba programming logics. But to understand OOPS in depth, it is very difficult, as it comes only with pure experience.
Okay.
Today I am telling, if you understand OOPS using Java, tomorrow all languages will be jujube in front of you, as Java is a mother of all programming languages.
Ooh.
You might say C is a mother of all programming languages, as everything originated from C. But no. Real-time application development started with COBOL mainframe, followed by Java JEE, which is still widely used in all enterprise applications today.
That is correct.
If you understand OOPS using Java, you will understand what is real-time industrial programming.
Oh, really?
ಅದ್ಬಿಟ್ಟು ಸ್ಟಾರ್ಟಿಂಗ್ ಪೈಥಾನ್ ಸೈಥಾನ್ ಅಂತ ಹಾರಾಡಿದ್ರೆ ಅದೇವ್ರೆ ನಿಮ್ಮನ್ನು ಕಾಪಾಡಬೇಕು. Polymorphism in Java means only one simple thing, that is one method having many forms. In Java there are two types of polymorphism. One is overloading and the other is overriding. Overloading in Java is called compile time polymorphism, whereas overriding in Java is called runtime polymorphism. Overloading in Java can be termed as early binding, whereas overriding in Java can be termed as late binding. Static polymorphism is another term for method overloading, whereas dynamic polymorphism is another term for method overriding. More about these terms we will be seeing as we get deeper into polymorphism. But for you to reach the topmost level, still there is a long way to go. Guru, is there any real-time example where you can demonstrate overloading? I still do not understand the purpose of overloading in Java. Well, in that case, we have to work on one more example on overloading. Take a look.
Real-time example for overloading.
In My Computer, go to D drive, Workspace and then go to Basic Examples folder. Here go inside the folder 11 oops and inside this click on 02 overloading folder which you had created in your yesterday's session. Create a new file by name demo2.java using the usual technique, and inside this file now let us start typing the code from line number 1. CLASS class in lowercase space MATH math in camel case and press the button enter. In the next two lines, make sure you enclose the class with flag braces now itself, as there is a chance you might miss them later, which may lead to compilation error. Inside line number 3, declare a method by name void add with no input parameters as seen over here. Similarly, in line number 7, declare one more method add to overload the first method with two integer input parameters. Now time has come for us to overload our add method one more time in line number 11 with two input parameters which is belonging to data type double as seen over here. What's the fun in overloading just 3 add methods? Let us overload the add method one more time with two input parameters. This time the parameters are belonging to the data type long. If a user tries to invoke the first add method with no input arguments, he will get a message like this. If a user tries to invoke the second add method with two integer input arguments, he will get a message like this. Similarly, if a user tries to invoke the third add method with two double precision floating point arguments, he will get a message like this. And if the user tries to invoke the fourth add method with two long integer arguments, he will get a fine message like this. Now what you saw is a newly created math template for you to create multiple math objects later in your program. It is time for us to now write class demo2, where inside this we declare our main method, and inside this main we now create a math object using the above math template. To create a math object in line number 25, all we need to do is write the code mathm is equal to new math. That's it. From now on, to invoke the add method present inside the math object, we need to pass the exact set of inputs as our arguments. That is, if we type m.add with no input arguments, the first method inside our math object will be triggered and invoked. If we type m.add 5, 6 with two integer input values as arguments, the second method inside our math object will be triggered and invoked. Now if we type m.add 22.18, 3.947, that is two floating point values as our input arguments, the third method present inside our math object will be triggered and invoked. And if we type m.add 7795L, 8576L, that is two long integer values as input arguments, the fourth method present inside our math object will be triggered and invoked. With this example, we can understand using a single method by name add, we wrote the logic for 4 different methods inside our math template. Now that's the power of overloading in Java. Super Guru, you're absolutely right. Why use different method names for each method when all methods are designed to do the same job? This truly explains the word polymorphism. One method, many forms. Till here we understood clearly. What is the next thing we're going to learn today? In Java, have you heard anything about instantiation and initialization? Instantiation, initialization, what? Oh, you don't know? Very important concept. Pay your full attention over here. They will definitely ask this question in your interview.
Okay.
Instantiation and initialization in Java.
If someone asks you in an interview what is instantiation, your answer should be the process of creating an object, also known as an instance or an example, using a well-defined class template in Java is known as instantiation. For example, consider a building plan we design for us to build a house. Using this plan, first we build a house in Bangalore, then we build a house in Chennai, and then we build a house in Hyderabad. All we are doing here is creating an example of this plan in Bangalore, creating an example of this plan in Chennai, and creating an example of this plan in Hyderabad. The synonym for example in English is instance. By this we can deduce we have created an instance of this plan in Bangalore, we have created an instance of this plan in Chennai, and we have created an instance of this plan in Hyderabad. So in the interview, if they ask you what is instantiation, the process of creating an instance or an example using a well-defined template can be termed as instantiation. The same theory can be now applied to our box object. Consider a box template which we worked on in our previous session. Using this class template, if I write the code box b1 is equal to new box, new object b1 is created, which is a replica of our box template. Likewise, if I write the code box b2 is equal to new box, new object b2 is created, which is also a replica of our box template present in a different memory address. Similarly, if I write the code box b3 is equal to new box, new object b3 is created in our JVM heap, and again over here it is a replica of our box template present in a different memory address. The first object b1 can be termed as an example of our box template which is present to our left. Similarly, the second object b2 and the third object b3 are also examples of the same box template which can be seen to our left. As I said before, the synonym for example in English is instance. By this we can deduce we have created an instance of box template which is referred by variable b1. We have created another instance of this box template which is referred by variable b2, and we have created one more instance of the very same box template which is referred by variable b3. So if you ask me the clear-cut definition for instantiation, the process of creating an instance or an example using a well-defined class template in Java is known as instantiation. Bravo! Super explanation, Guru. Yellow kaladobute. If we understand what is an instance, instantiation is a process of creating that instance. Very easy definition. Now teach us what is initialization, no? In your interview, if they ask you what is initialization, your answer should be the process of assigning values to all the instance variables present, aka states, after creation of an object is known as initialization. That's it. Astena, setting up values for instance variables. I thought initialization would be some big process. Nin talakai burude. What does the word initialize mean, man? Keeping things ready before you start using an object, tane? Yes! That is why setting up of values for your instance variables is known as initialization.
Okay.
Now, are you aware of 3 different ways that we have come across to initialize our box object? Yeno 3 ways ah? Meaning sudden ಆಗಿ ಕೇಳ್ಬಿಟ್ರೆ ನಮಗೆ ಹೆಂಗೆ ಗೊತ್ತಾಗುತ್ತೆ? ಹಾಳಾದ ನಮ್ಮ ತಲೆಯಲ್ಲಿ ಏನು ನಿಲ್ಲಲ್ಲ. Can you please refresh our memory?
3 ways to initialize an object.
Consider our box template where we have already pre-coded the values of L, B and H to 5, 5 and 5. Now suppose we create an object of this template by saying box B is equal to new box, boom. A new box object is created in the heap memory with all the values prefixed inside 5, 5 and 5. This way of initializing an object by pre-coding the values inside the class template is known as hard coding. I had taught you what is hard coding a long time ago while I was teaching you basics. Hope you still remember. Oh, hard coding ah? Yeah, I remember. This is the first way to initialize a box, right? Now what is the second way? Consider the latest version of our box code wherein we have not hard coded any value for our instance variables present inside the box template. But if you observe the code inside the main method, first we create a new box object using the code box b is equal to new box, and after this we have written some code to initialize the above box object. Once the first line of code box b is equal to new box gets executed, kaboom! New box object is created inside the heap memory as seen over here. Please note, we have still not initialized any values inside our object. As a result, the JVM has just assigned default value for these instance variables as 0. Now when the program control executes line number 6, line number 7 and line number 8, using the dot operator, we now change the values of LBH inside this object, boom, as per the code written inside the main method. This way of initializing an object is known as initializing values using a dot operator. Oh, ida! Using dot operator we know how to assign values. Now tell us, what is the third way we use to initialize an object? Consider the same box template with no changes made to its variables. The box template also has a method inside by name setBoxSize, which is used to set the values of variables present inside the corresponding box object. Now inside the main method, if we write the code box b is equal to new box object will be created inside our JVM heap memory like this. Please remember, we have still not initialized any values inside the object, and as a result, the JVM has assigned default values to these variables as 0. When the program control executes line number 6, that is b.setBoxSize 5,5,5, the object will be initialized boom as the code what is present inside setBoxSize method initializes the values using the input arguments what we send. This way of initializing an object is known as initializing an object by invoking a suitable method. With this, I have properly covered 3 ways of initializing an object. The first way was initialize using hard coding. The second way was initialize using a dot operator. And the third way was initialize using a method invocation, that is by invoking setBoxSize method, which you have already worked on in our previous examples.
That is correct.
All 3 ways were in fact very basic, but each of the technique to initialize the box object was actually cumbersome in its own way.
Uh-oh.
If you are thinking, is there any simpler way to initialize an object? Yes, there is one. Constructor. ಏನು ಕನ್ಸ್ಟ್ರಕ್ಟರಾ? ಕೇಳೋದಕ್ಕೆ ಭಯಾನಕವಾಗಿದೆಯಲ್ಲ ಗುರು. See, now only I am warning you. Without learning constructor in Java, you can never ever progress to any further topics. To understand and learn what is a constructor, which is a short interview question, there is only one way. Making notes and working out all our previous examples. Without working on previous examples, if you directly jump into constructors, the future examples are so difficult. I am pretty damn sure that you will break your teeth as you are acting too much overconfident.
Oh no!
True confidence only comes by practicing every example what I teach and by making notes on what I tell.
Yes!
The real advantage of making notes is you can go instantly revise your previous topics if you by any chance get stuck somewhere in the middle.
Okay!
Not just that, before attending any of your interviews, it is practically impossible for you to see all my videos in one single day. The definitions what I give in my class are so precise, they are always 100% to the point. You will never get these definitions in any textbook or in Google or on the internet.
Oh, really?
These definitions are trimmed and are purely custom made by me to fit the current day interview standards for any company.
Thank you very much.
If you miss writing these definitions in your notes, you will answer ta-ta-ta, in your interviews, guaranteed. Now let us start with the most important topic, in fact very important topic in Java, constructors.
Constructors in Java.
Constructors in Java are the most powerful members in a class which will be used for object initialization. The special ability of a constructor is it will be invoked only once during creation of an object. Always remember, a constructor can be invoked only once in a lifespan of an object. Guru, seriously, if you keep telling these theory points, how can we understand? Teach us how to write a constructor, no? Later we will only figure out what is a constructor.
How to write a constructor in Java.
Before we learn how to write a constructor, let us first create a new directory for our constructor examples.
Okay.
In my computer, go to D drive, workspace, and then go inside our basic examples folder. Now inside the previously existing 11 oops folder, create a new directory by name 03 constructor. This is the place where we store all our programs bar examples related to constructors. Go inside 03 constructors folder and now create a file by name demo1.java. Here in this file, we write our first program related to constructors. The basic thumb rule we need to follow before writing a constructor is, a constructor will have the same name as our class name for a given class template.
That is correct.
Guru, please stop giving us these thumb rules and all. Adena ಹೇಳ್ತಾರಲ್ಲ ಮಂತ್ರಗಿನ್ನ ಉಗುಳೆ ಹೆಚ್ಚು ಅಂತ. For how long you will be teaching us theory? Show us how to write a constructor, no? Now inside your source code demo1.java, let us start typing the code. CLASS class in lowercase, BOX box in camel case, as it is the name of our class, and now press the enter key for us to go to the next line. Open and close the flap braces here, and from line number 3, declare the integer variables L, B and H, which represents the length, breadth and height of the corresponding box object. Please note, we are not hard coding any of the values to our instance variables here, as we are going to initialize the values using a constructor. After declaring the instance variables on top, it is now a right time for us to type the code for the one and only constructor. In the first line of our constructor, type BOX box, which is the same name as our class name, and inside the parenthesis start typing int x, int y, int z, which acts as the parameters for our constructor. Open and close the flap braces which demarcates the body of the constructor, and inside this write the code as L equal to x in line number 8, B equal to y in line number 9, and H equal to Z in line number 10. The above code what you are seeing in line number 6 to line number 11 is the constructor code for our box template. As I have said before, we will be using a constructor to initialize an object. The code written inside the body of this constructor is pure initialization logic for the instance variables L, B and H. Now inside the box template, after declaring our constructor, do declare the other methods print volume, fetch surface area and set box size, as they are also an integral part of our class box. Once you finish writing the code for our box template, it is now time for us to create a box object using that template. Oh yeah! In line number 34, to create a new box object, never write the code as box B is equal to new box. Instead of writing the usual stuff, we should now type the code as box B is equal to new box of 5, 5, 5 or whatever values you would like to initialize. To cross verify whether the values 5, 5, 5 have transferred into our object or not, add 3 more SOP statements in line number 35, 36 and 37 that prints the values of variables L, B, H directly from the object using a dot operator, accessing it using variable B. Compile the code by pressing Ctrl 1, for which you should get 0 compilation errors, as the code what you have written here is absolutely valid. Once the program is compiled successfully, press the shortcut Ctrl 2 and kaboom! An object of box is created in the JVM heap memory whose instance variables are assigned with values 5, 5 and 5 what you had passed as arguments during the creation of this object in line number 34. Don't expect to see any color objects being created on your computer screen, as this is just a virtual image we are showing for you to imagine how your objects will be. Well, if you want to confirm whether the values are properly initialized or not, just analyze it by seeing the output of these three SOP statements here, here and here. Oh, so the constructor is like our setBoxSize method, where we initialize the object using the arguments, right? Yes, a constructor in Java acts as a special method which has the same name as our class name, and most of the programmers use a constructor to write their initialization logic within.
Ooh.
In real life, that is inside of a building example, if you ask who is a constructor, it is the civil engineer who takes charge of building the house for you as per the plan. Yes, the civil engineer acts as a constructor in real life, as he is the one who takes the decision on ground about how to build a house in real time. Guru, in what way a civil engineer acts as a constructor? How can he be related to our box constructor in Java? To understand how a civil engineer is related to constructors, take a look at this illustration. Consider an imaginary scalable plan wherein you demand your engineer to build a 2-story bigger house. The engineer instructs the same to the mason, and the mason starts his work to build a 2-story house using the same plan what you have provided. Suppose if you instruct the engineer that you want a 3-story bigger house, he will instruct the same to his mason in real time, and the mason will build a 3-story bigger house for you using the same plan what you have provided. So that is why with the help of a constructor, you in real time give an object an exact shape and structure during its creation phase. Okay, an engineer is a true constructor of a house, as he is the one to decide in real time what is the actual size of the house. But my question to you is, how does a constructor in Java acts as an engineer to our object? A constructor in Java also works the same way with regard to initialization of an object. Consider the current box template, which has a box constructor declared with 3 input parameters, that is int, int and int. To the right side inside our main method, if we declare box B and create a new box using the above mentioned constructor, that is by passing the arguments as 5, 5 and 5, an object during its creation phase will invoke the box constructor as shown over here. Please note the constructor will be the first member to be executed in this object, and the object will be in initialization phase till the constructor finishes its execution. Once the constructor finishes its execution, the initialization phase of an object completes, and boom, variable L, B, H are initialized to numerical values 5, 5 and 5, making our object completely ready to use. So by this logic, a constructor is the first member to be invoked inside our object. Yes, a constructor in Java is the first member to be invoked during the creation of an object.
Ooh.
Any values you pass as arguments to a dedicated constructor, the JVM uses the constructor logic to initialize an object during runtime.
Okay.
Nice. So how exactly a constructor will be executed in Java? Just like a method, not much of a difference. A method when invoked gets loaded on top of the stack. Likewise, a constructor when invoked also gets loaded on top of the stack. Why don't you see it for yourself?
Okay.
Constructor working in Java.
In the program what we have typed just today, we have a constructor declared with 3 integer input parameters. This means to invoke the following constructor inside our demo code, we have to pass 3 integer values as arguments for the compiler to match the input. Please note, we cannot invoke a constructor using a dot operator just like any other method. Here we specifically have to use a new keyword to invoke a constructor in Java. After writing the new keyword, please make sure the input arguments what you are passing, that is int, and int in this scenario should exactly match with the input parameters declared on the constructor which is present on your source code. If at all you send some random values as arguments which does not match with the constructor signature, you will get a compilation error, and when that happens, please don't blame me later. Now as we run the above code, construction of the new object will begin in the heap memory. To initialize the variables inside this object, the JVM will invoke a respective constructor by making an entry of this invocation in JVM stack as shown over here. Now as the constructor invocation is present on top of the stack, the execution begins. The arguments here, that is 5, 5 and 5, will fit inside the variables x, y and z, leading the program control to enter the body of the constructor, that is over here. When the program control reaches the statement L equal to x, the value inside local variable x gets transferred to instance variable L, which is present in the currently executing object. Likewise, when the program control reaches the statement b equal to y, the value inside local variable y gets transferred to instance variable b, which is again present in the currently executing object. Similarly, when the program control reaches the statement h equal to z, the value inside local variable z gets transferred to instance variable h, which is present in the currently executing object inside our JVM heap. Once the program control reaches the last line of our constructor, the entry on top of the stack gets erased as the constructor now is completely executed. By this we can say, using a constructor we have successfully initialized all variables inside our object, all with the help of invoking a constructor. Congratulations! Wow! Using a constructor we can initialize an object while creating it in the first line itself. In fact, it is even more easy compared to our other 3 ways. But dude, what if we want to invoke the constructor one more time? That is to reinitialize the instance variables. Can we use a dot operator to invoke a constructor, or we have to use the new keyword one more time? Like Gubaldo, how many times to tell you? A constructor can be invoked only once during an object's lifetime anta. This is a place where all my students fail to understand.
Confusion alert.
Many students are still not clear how many times a constructor can be used in an object. Please note, a constructor in Java will be executed only once during the creation of an object and definitely not after that. A constructor in Java can only be invoked using a new keyword and not with the help of a dot operator by any chance. For example, in demo1.java, inside the main method we can write box b is equal to new box 5, 5, 5, which means we are creating an object and initializing the same using a constructor within the same line. We can change the values of box object later using a dot operator and a reference variable like this. But we cannot invoke the same constructor by typing b.box 10, 20, 30 or b.box 5, 6, 7 or b.box 5, 5 once again, because constructors in Java cannot be invoked using a dot operator. Remember, you can invoke a constructor using a new keyword only once, that is during creation of that object. If at all you want to change the values, do it individually by using a dot operator or invoke the setBox size method with different set of arguments, which is in fact the right way for you to change the values present in an object. Dude, I understood that we can invoke a constructor only once using a new keyword. But I did not understand why founders of Java made it that way. Why didn't they allow a constructor to be invoked multiple times? Founders of Java had their strong reason to avoid multiple invocations of any constructor.
Oh, really?
They wanted you programmers to dedicate constructors to write only logic pertaining to initialization of object level resources during the creation of an object.
Yes!
If you want to invoke the constructor again and again in a single object, then what would be the difference between a constructor and a method? ಅರ್ಥ ಆಗಲಿಲ್ಲ. Very simple. You will invite an architect or a civil engineer only during the construction of a house.
That is correct.
Once the Griha Pravesha is done, that's it. Their job is over. They will eat chiroti uta and say tata bye bye forever. Now after 2 or 3 years, if there is a leakage, or you want to change the paint, or you want to shift the commode as it is not fitting your vastu, even if you give them 1 lakh, they will not take up the job. Reason is they don't know how to handle patchworks, or they will be very busy with their fresh projects. Now there is only one option for you to repair the house. That is, you have to hire your own plumber, your own painter, and you have to hire your own mason to fix all these petty things. Likewise, constructors in Java are also like your engineers and your architects. They will only help you during the creation of your objects. Once the object is ready, katam gatam. You cannot invoke them or invite them again and again whenever you feel like. It is completely invalid. Abba! Now I clearly understand what is a constructor and how it should be used. Hello boss, this is not a last chapter on constructor. In tomorrow's session, we will be having even more maja. You have not even understood this much about a constructor. It is just the basic thing what I have taught you. Now let us start learning an important topic. Without learning this, you can never ever clear any technical interview in Java. Members of the class.
Members of the class.
Consider a box template in our source code demo1.java. From line number 3 till line number 5, we have declared 3 variables, that is int L, int B and int H. These variables here are known as instance variables, as these variables will be a part of all instances, aka objects. Now coming to the behaviors, we all know that print volume, fetch surface area and set box size belong to a single category called instance methods. We call them instance methods because these methods will be present in each and every instance, aka objects, created using the above box template. Last but not the least, we have added one more member to our class family today, that is constructor. Just like our instance variables and methods, a constructor will be present in all our objects created using the above template. These instance variables, constructors and methods inside a class template can be collectively called as members of the class. Oh, I had thought only instance variables and methods belong to members of the class. Now constructors also belong to the same group. Hello Swami, still so many members are pending, which will be added to your members of the class list. To teach all the members of the class, I need one full series. So have some patience and be prepared so that you won't get confused tomorrow.
Oh.
Without understanding members of the class, learning Java is useless. Keep that in mind.
Okay.
Now it is time to identify local variables and instance variables present inside a class template.
Local variables inside a class template.
In our box template present inside the file demo1.java, variable int x, int y, int z declared inside the constructor, variable int surface area declared inside the method fetch surface area, variable int volume declared inside the method print volume, and variables x, y, z declared as parameters in setBox size method are specifically known as local variables. Local variables are not included inside members of the class because they are only local to that method or that constructor, as they don't belong to the overall template. Oh, so local variables belong only to that particular scope. Nangid gotte irlilla. Nee bidappa. If I teach you 1,000 times also, you will be committing the same mistake. I had taught you this in life scope of variables. Still you have forgotten means your brain should be kept in some museum like Sir M. Vishweshwaraya. Take down this assignment and practice. Maybe in future you will not repeat the same mistake again.
Mini assignment.
Identify the local variables and instance variables inside the given box template. This is a compulsory assignment for everyone and you should practice it with full attention. Don't try to skip this by cheating me, as it will be equivalent to self-cheating. Answer for this mini assignment will be provided at the end of this video.
Mini assignment.
Write the constructors to initialize all instance variables of class cat and class dog. Create both objects of class cat and class dog inside a single main method using constructors written by you. Now this assignment is very important. Do not ever try to miss it or you will land up in soup later. Okay, time has come for me to end this session. Do work out all the assignments I have given you in this chapter and please do make proper notes or else you will end up in soup later.
Okay.
Do text us your doubts on WhatsApp if you have any so that we can solve it for you. Remember, you understanding the subject is our topmost priority. Do share this video series with your friends and encourage them to buy it on our website www.brainsmartlabs.com. This will give us a financial aid to bring more and more programming videos for you. Do like our Facebook page to receive updates on our new upcoming video series. Till then, this is Balaji Kayas signing out and you know what to do. Muchkond kodu ಮಾಡಿ bye bye.